Let's take a look at microbes as either villains or heroes. What do I mean by that? Well, the first one, this is pretty obvious. Microbes make us sick. There's no question about that. However, we also need to understand that our lives are dependent upon microbes as well. So if we're dependent upon microbes, how come they make us sick? We're going to tackle that in our next few slides. Let's move on to the next one. The villainous microbes then are responsible for causing infectious disease. We need to augment this slightly if we're going to develop a proper understanding of disease and how it impacts humans over time, the relationship that exists here. Let's call them so-called villains because they really don't mean any harm. They're just doing what all life does. It feeds, it reproduces, and unfortunately sometimes it produces toxins. Parasitism is ultimately a fact of life. William McNeill, in his famous book, Plagues and Peoples, talked about a relationship or juxtaposed the idea of microparasitism versus macroparasitism. In the case of bacteria, for example, and how it impacts our bodies, we have microparasitism. In contrast, humans, we're disrupting balances all around us. We are, in fact, causing drastic climate change and threatening the existence of many animals here on Earth. This is something that he refers to as macroparasitism. So a key point here is we need to understand that it's this inability to establish a relationship between an infectious agent and the host. That's what causes sickness. It's that imbalance that emerges. Homeostasis is disrupted. There are a number of categories of infectious causative agents. Let's briefly run through these and make sure that you've highlighted them in your textbook. So number one, we have bacteria. Bacteria is in fact the oldest form of life on Earth. It's a superhero, as we're going to learn shortly. In addition to bacteria, we have protozoa. For example, malaria is caused by a protozoa, Plasmodium falciparum. We also have helminths or worms. For example, a tapeworm or a roundworm and a scarred worm would be a type of helminth, and we can pick that up by eating improperly cooked meat, for example. We also have viruses. Now, viruses are really interesting. They're kind of like the living dead. They don't have their own metabolism. It's only once they gain entry into a cell and they begin to take that cell over, they insert their DNA or RNA, and then they take that cell over. It's kind of like a zombie. Finally, we have another class that we refer to as prions or infectious proteins. And as I discussed, if I haven't discussed it, I will get to it. A couple of different classes going on here. However, Kuru sorcery or transmissible spongiform encephalitis, CJD, was the first discussion of these infectious proteins. And a fascinating story, and not only do they infect humans, but we've also seen it in the case of mad cow disease. So a couple examples of prion disease. Let's move to the next slide. If you go to table 5.1 in your textbook, we see those categories of infectious microbes. This is a good area to bookmark and come back to. It gives us quick information. So we have those pathogens that we've just discussed: bacteria, protozoa, helminths, viruses, and prions. Really briefly, and your textbook tells you a little bit more, but I'm just going to highlight a couple of areas here. Bacteria, as a type of life form, like I said, it's the earliest life form, and it's unicellular. It's referred to as a prokaryotic form of life. A couple of examples of diseases that are caused by bacteria would be anthrax. Lyme disease or Borrelia burgdorferi is the bacterium there. Brucellosis, we can pick that up by eating or drinking unpasteurized milks and cheeses, and tuberculosis as well. As for the protozoa, this is also unicellular. It's a eukaryotic form of life, And a couple of examples would be malaria. That's a disease that's caused by a protozoa, or traditionally what we refer to as a parasite, or trypanosomiasis. That's African sleeping sickness. We'll talk more about that stuff a little bit later on. Helminths, they're multicellular animals. So Ascarid or Ascaris infection, that's a type of roundworm we can pick up by eating improperly cooked pork, beef, or even fish. Or schistosomiasis, sometimes referred to as Bulgaria. That's something that we can pick up in areas that are snail infested, and there's a cycle that exists between humans, snails, and more humans. Schistosomiasis mansoni. Viruses, in contrast, they're undefined. They require a living cell to come alive. They insert their DNA, and from an evolutionary perspective, they are in fact fascinating. There's some research that suggests that maybe life here got started as a result of viruses who inserted their DNA or RNA into early forms of bacteria. Now, this isn't ancient alien stuff. If you're thinking that stuff is way off the mark. However, possibly this stuff got to Earth via an asteroid or a meteorite. Like I said, we're not entirely sure. People theorize, and we're still trying to figure out how the fundamental stuff of the Earth got started. Either way, viruses cause some of the most horrific types of diseases, for example, such as Ebola, to more milder types of diseases like influenza. Of course, smallpox, which is eradicated in 1978, a horrific disease which has probably killed more people than any other disease on the face of this earth, to something quite simple as the common cold. Now, the thing to remember about a common cold is at one point of time, it wasn't that common. And the viruses that are responsible for the common cold, for example, coronaviruses, we're seeing right now how dangerous that virus can be when it just emerges, when it spills over from a non-human animal population. Eventually, the theory is this will start to become endemic. It'll start to move within the population and begin to circulate. And hopefully, its virulency, fatality rates will begin to reduce over time, just like other cold viruses. We've referred to prions. This is an infectious protein, and a couple of really good examples in our textbook are CJD and TSE. So make sure you take a look at that stuff. Let's move on to the next slide. I've referred to micro and macro parasitism, and here I'll give you an opportunity to write down a few of the ideas. So number one, I said bacteria, viruses, protozoa, helminths, they're all forms of life. We don't need to write all this down. We can just write bacteria or other microorganisms equal forms of life, or just life. Try to shorten some of your notes. Disease, in the end, it's a product of imbalance. And in the same way that we feed, we reproduce, and really we produce a lot of waste, the same thing is true of bacteria, for example, and protozoa and helminths. They produce waste. They continue to reproduce, and when their numbers become too high, in the same way that we put a strain on the system, they also put a strain on the system as well. Microorganisms, then, we need to understand that they are not the disease. They cause disease. Looking at this idea of micro versus macro parasitism, it would be like referring to humans on a global scale, climate change scale, as we are the disease of the earth. Well, we're not the disease of the earth. We're causing a type of diseased earth. There's no question about that. We're accelerating climate change. We're producing waste, lots of toxins. However, we are not the disease. We're an organism that unfortunately has started to reproduce to numbers that just perhaps are not sustainable, and we're producing a lot of waste in that process, and we're doing a lot of feeding on the earth itself. Let's move to the next slide. Let's take a look at tuberculosis to gain an understanding of the difference between disease, the agent that causes disease, and let's pose a question here. Is it possible to have a disease and not be sick or ill? Think about that while we talk. Tuberculosis, this is referred to as the disease. This disease is caused by Mycobacterium tuberculosis. Now, Mycobacterium tuberculosis, we're going to find it also has some ancestors, so evolution, this is something we are going to talk about and we need to understand. Now, Mycobacterium tuberculosis is a slow-growing bacterium. And of the people that contract tuberculosis, 90% of those individuals remain in a latent state. In other words, they don't develop symptoms, nor do they spread tuberculosis to other individuals. When balance is disrupted in the body, this is when tuberculosis becomes a problem, or Mycobacterium tuberculosis becomes a problem. It starts to reproduce, generally speaking, with individuals, for example, that have a compromised immune system or another illness. Their cases end up being what we refer to as active tuberculosis. So in this situation then, if we look at the 90% of individuals that contract tuberculosis and remain in a latent state, we can say that they have a disease, but they're not sick or ill. In contrast, that 10% that is moved to active, they are sick and they will be ill. A few points here. On a yearly basis, the World Health Organization and the CDC report 10 million new cases of TB. In fact, TB appears to have infected at least 1/2 of the Earth's population on a global level. Now, latent TB, as I've pointed out, there's no symptoms, there's no sickness, and it's not infectious. Latent TB, it can develop into active TB, and this is generally speaking with a compromised immune system. 10% of people move into active TB. Now, active TB, that is infectious, but it is curable unless we have multi-drug resistant forms of TB bacterium. Now, this is a health crisis, especially in areas of poverty. So what's happening here with multi-drug resistant TB is it has become immune, for example, to antibiotics. And in some situations, the only way to treat these cases would be with chemotherapy. Let's move to the next slide. While we tend to think of microbes as villains, something that's always out there to get us, we need to remember that bacteria, microbes, they can be heroes. And here, let's take a look at bacteria. They are, in fact, heroes. Let's move to the next slide. So with respect to heroes, you're probably thinking of Batman or Superman. Actually, I'm thinking more of a mutant like the X-Men, something more like the Beast, for example, with its superhuman strength, or perhaps the Cyclops. Now, while this has great optic blast, we're talking about a much more important superpower here. You're wondering, is it anything like the Archangel? Maybe massive quads is this individual superpower, or Jean Grey. She knows exactly what you're thinking right now. Actually, the first mutant superhero had just this amazing superpower that was responsible for pretty much everything today. Let's move to the next slide. Now, in this narrative, you might feel that I've ripped you off, but mutant cyanobacteria, they are a superhero. Their superpower is photosynthesis. How's that? Let's move to the next slide. How then is bacteria a superhero? Well, according to Andrew Nikiforuk, he says the collective farting, belching, and shitting, pardon me, I'm quoting him, of bacteria produced our atmosphere. Now that's amazing. So when we look at bacteria, we can't always understand it to be something that's bad, something that's negative. It is necessary in a variety of different ways. Let's take a look at our own system. Let's move to the next slide. We need bacteria. In fact, we're teeming with life that goes beyond the life that we recognize. This concept is called the microbiome, and we know that we have some 500 to 1,000 species of bacteria living in our gut and on our skin. Looking at this, in contrast, we have about 10 to the power of 14 human cells, and in contrast, 10 to the power of 15 bacterial cells. We are, in fact, a whole lot of bacteria. Some people have proposed that humans may be better understood then as a system of organisms rather than one individual. We are, in fact, an ecosystem. In the end, we need bacteria to survive. What I want you to do now is move on to the next slide, and there you're going to find a link to a video on archaeogenetics that's going to talk about dental calculus and what we can learn about past health by looking at that material. Take care.